Hello learners. Let me start with something you do every day. When you look into a mirror, do you ever wonder how does your entire face appear with two eyes, a nose, and even that one stubborn pimple? The mirror isn't taking a photo of you, it's playing with light rays. Here's the secret. Every point on your face, say the tip of your nose, sends out light rays in all directions. To find where the image of that point is formed, we don't need to chase all those rays. Just two are enough. Each ray strikes the mirror, reflects according to the laws, and where the two reflected rays actually meet or appear to meet gives us the image of that point. Repeat this for all points and voila, your whole face stares back at you. Now let's talk about the first type of image, the real image. A real image is formed when the reflected rays actually intersect after reflection. Here's the cool part, since rays physically meet, you can capture this image on a screen. Movie projectors work exactly like this. But there's a catch. Real images are inverted compared to the object. So if you're standing on your head in front of a concave mirror, wait, scratch that. The mirror will already do the inverting for you. For example, when you use a concave mirror to focus sunlight, the bright spot on the paper is a real image of the sun. Now comes the trickster sibling, the virtual image. This is formed when the reflected rays do not actually meet, but they appear to diverge from a common point when extended backward. Virtual images can't be captured on a screen because there's no actual meeting of rays. But they are always direct with respect to the object. Think of your bathroom mirror. The image of your face inside it is virtual. The rays never actually come from behind the mirror, but your brain swears they do. Same story with convex mirrors, like those wide mirrors in shops that make you look smaller and further away. Now, how do we find exactly where these images are? That's where ray diagrams step in. For a virtual image, we draw the reflected rays and extend them backward. Where they seem to meet is the image point. For a real image, we follow the actual reflected rays forward. Where they converge is the image. By locating the image of many such points, we can join them and reconstruct the full image of the object. This is how we prove whether an image is erect, inverted, real, or virtual, all using simple geometry and lines. Okay, let's put real and virtual images head to head in a showdown. A real image is formed by actual intersection of rays. A virtual one by apparent intersection. Real images can be thrown on a screen. Virtual ones cannot. Sorry, no selfies on screen here. Real images are inverted, virtual images are erect. Example of real image, a concave mirror focusing light from a distant tree. Example of virtual, your reflection in a plane mirror. So, one is real but upside down, the other is fake but at least keeps you upright. Let's cement this with an example. Suppose we place an object beyond the center of curvature of a concave mirror. Step 1. Draw a ray parallel to the principal axis. After reflection, it passes through the focus. Step 2. Draw a ray through the center of curvature. It retraces its path. Step 3. Observe where these rays meet. They intersect between the center C and focus F. So what do we get? The image is real, inverted, and smaller than the object. And yes, this image can be caught on a screen. This is why concave mirrors are used in telescopes and shaving mirrors. Depending on distance, they can magnify or minimize.
Alright, time to wrap up. Image formation by reflection relies on tracing at least two rays from each object point. If the rays actually intersect, you get a real image, inverted and screen obtainable. If they only appear to intersect, you get a virtual image, erect and non-screen obtainable. Plane and convex mirrors form only virtual images. Concave mirrors are versatile. They can form both depending on object position. So, the next time you admire yourself in a mirror, remember, it's not a magic trick, it's pure geometry of light at play. Physics is the real selfie master. I hope you enjoyed this journey into image formation. See you in the next session where we'll reflect, pun intended, on another fascinating concept of physics.